Again, an equal sign means that it's an equation. If A equals A, true? It's a true statement. This is what's called a reflection. The reflective property of equality. If A equals B and B equals A, then they're symmetric. This is proved by the symmetric property of equality. You see what I'm giving you the shorter word. So we don't, if I say symmetric, it automatically means symmetric property of equality. We just say it's symmetric or reflective. If A equals B and B equals C, then A equals C. You ever seen that one before? If A equals B and B equals C, then A equals C. That's called the transitive property. Or the transitive property of equality. There's different ways we can look at how things are equal to each other. Now, the algebra of equality. If A equals B, and if I add the same number C to both sides, are they still equal? Yes. There's so if you add the same value to both sides, they are still equal. Does that work for subtraction? If A equals B, does A minus C equals B minus C? Yeah, because A equals B. It's the same number. I'm just, if I subtract the same number from the same number, I get the same number. And it made you think about it. Because once you put subtraction in there, you start thinking twice about it.
Because it feels like split over at C minus B,
That's why it's not commutative. Symmetry is not commutative. If A equals B, and I multiply C to both sides, they're the same thing. So multiply the same value to both sides. They are still equal. Don't like this pen. Does it work for division? As long as C is not equal to 0. So we say that it's symmetric, it's transitive, it's everything with all the possibilities, all the properties. Now, when would we use something like this? Give me an example.
An angle side of a triangle, and they give you a smaller triangle, and there's a bigger triangle. And the smaller has all the sides.
As long as you're missing one unknown. Okay, yes, that'll work. Basically, yeah, what you're getting to is this is how we prove things mathematically. Use these to prove equality. So if x plus 5 is equal to 7, that's equal, so the same. So whatever I do to one side, I do the other side. I want to get x by itself. So how do I get rid of a positive 5? So I subtract by 5. Since I subtracted by 5 here, I have to subtract by 5 here, which is why we use these properties to help us solve for variables. Those are called the cancellation properties. If A plus C equals B plus C, then what makes them equal is if A equals B. Why is that important? Because C is the same thing as C. The only way this can be difficult is only be equal sign is if A equals B. So again, how do we get A by itself? Cancel, subtract by C, and subtract by C, and you get the same value. Same thing with the multiplication. If A times C equals B times C, then A equals B. Because I divided by C both sides. The zero product property, very, very powerful tool in algebra or mathematics in general. Zero product, what it's saying here. What does product mean? Yes, exactly. So if I have A times B is equal to 0, then what has to be true? For this to be true, what has to be true? Or both of them. So A equals 0 and B equals 0. We don't know which one, so we solve them both. When do you use this? In algebra. If we want to know what this equation, where it crosses the x-axis, we would factor it. We would get x plus 2 and x plus 3. Since the whole thing equals 0, then this is a times b equals 0. So x plus 2 equals 0 and x plus 3 equals 0. I solved for these. How do I get x by itself? Subtract 2. So x equals -2, and do this one, subtract 3. X equals -3. So this is where my graph is equal to 0 at -3 and -2. So that's the powerful reasons why we use these. Are these equal, or if are they equal, less than, or greater than? Well, let's work it out. So 2 times 3 is 6. This one is 3. 2 times 2 is 4. 3 plus 4 is 7. So 6 is less than 7. There's one of them. So what do these have to be? If I want it to be equal, what does it have to be? What does a square have to be? What does a triangle have to be? Yeah. Square would be 2, and the triangle would be 3. Are there any other answers? How about if this one was 4 and this one was 6? So there's an infinite number of answers here, as long as they have this ratio, this connection. So I could put 6 here. I could put 9 there. So notice I'm adding 3 here. I'm adding 2 here. So there's an infinite number of answers. So what is the value of a triangle and what's the value of a square? I'm going to say these. I'm going to give you this. So since this is the only one that has a number on it, we have 2 triangles equals 18. So how much is each one of these triangles? Yeah. So we have 2 times triangles equals 18. Divided by 2, 1 triangle equals 9. So each triangle is 9. 9 plus 9 is 18. So if this equals 9, how much is each one of these? Yeah. So 3 times each square equals 9. So each square equals 3. And there you have it. Well, they're multiplied, or But all you know, there's no operation because these are objects. It's two, you have two triangles and they equal 18. How about this one? How would you solve that one? When you solve for x, remember, okay, first that order of operations. What's the first thing you do in order of operations? Special operations. Parentheses, brackets, square roots, absolute values. Then the next thing you do in order of operations, multiplication, division. And then you do addition, subtraction. This is the way you do order of operations. When you solve, go backwards. The first thing we have to do is get rid of plus and minus. Because we're trying to get to x. So anything that's not x, get rid of it. So we would add 14 to both sides. Okay, no more plus and minuses. So get rid of multiplication division. 3 times x. How do we get rid of 3? So x is equal to 5. And there's your answer. And then plug it back in the original equation. Always check your answer with the original equation. Why?
Yeah, make sure that-
Well, could I do it here also? 3 times 5 is 15. But what if? What if this was wrong? The only thing that's not wrong is that. That's the only thing that's not wrong. That you can be sure of that because that's the question. So always check with respect to the original equation. So let's look at a couple of examples. What's my first step?
would be 1x.
Yeah, because all the x's on one side. X's are the important, so move that first. Move smaller x to larger x. So here I subtract x from both sides. So it's 3 minus 1 is 2x equals square root of 10. So x is the square root of 10 over 2. Okay. Another example. Fractions. Whenever you have when you have fractions and an equal sign, get rid of the fractions. Here are the steps. 1. Find the LCD. In this case, in this equation, what is my LCD? Three. That's it. It's the only denominator is 3. Multiply each term by the LCD. So it's 3 times 4/3 x equals 3 times 33x minus 3 times 1/3. Remember, a term is anything separated by a plus, minus, or equals. Step 3. Cancel. So the 3's cancel. So we have 4x. 3 times 3x. And the 3's cancel. We're just left with 1. Out of the first and last equations, which one looks easier? This one. But that's the reason we got rid of the fractions. It's the same equation, just looks different. Multiply to remove parentheses. And then solve. Remember what I said? What do you move here? Nope. Always move smaller to larger. If I move the 99, it's gonna make it negative. And you have a big chance of making a mistake. So I move this one. Subtract 4x from both sides. Now get rid of this one. So I add 1 to both sides. Those cancel. Because now you don't have to worry about anything. The answer is what the answer is. No sign changes or anything. So x is equal to 1/95. Make sure we gotta hurry up yet. We don't have much time left. 4x plus 3, 5x plus 3 equals 99. First step here, get rid of parentheses. Get rid of parentheses. 2, combine like terms. 4x plus 5x is 9x. 12 plus 15 is 27. And then solve. Right. So that's end of that section.